right, so far we've been talking about ionic compounds. Now we're going to talk about molecular compounds and covalent bonding. Now in covalent bonding, electrons are shared. So one example of molecular compounds of this covalent bonding are these elements here. They cannot exist by themselves. So for example, fluorine is going to share electrons. There are two fluorines and they share electrons together to form a covalent bond. Okay, and that creates a fluorine molecule. Other examples include CH4, carbon is sharing electrons with hydrogen. Okay, NH3, nitrogen is sharing electrons with hydrogen, and water. Now, for naming, unlike ionic compounds where you simply write the name of the metal followed by the nonmetal, when we're dealing with covalent bonding, we have to use prefixes because we have two nonmetals. We don't have a metal and a nonmetal. Okay, so the prefix tells you how many atoms you have of a specific element. So for example, mono is 1, di is 2, 3 is tri, 4 is tetra, 5 is penta, 6 is hexa, 7 is hepta, 8 is octa, 9 is nona, and 10 is deca. So let's look at an example. Here I have CO, so I know I have 1 carbon and 1 oxygen. The only additional rule you need to know is you do not start the name of a compound with mono. So instead of monocarbon, because there's 1 carbon, I'm just going to write carbon. And then I do have just 1 oxygen, so it's going to be monoxide. Now to write the formula, I simply have to use the prefixes. So this is carbon tetrafluoride. So carbon, I have 1 carbon, and then I have 4 fluorides, so it'd be just CF4. So no crossing your charges here. Now there's a lot of information that's been given to you, so let's distinguish between ionic and covalent compounds and how to write their formulas. So if I'm given the name of the compound, this part's going to be review. If I have a metal and a nonmetal, this is ionic. Okay? To write the name, what I have to do, to write the formula, what I have to do is I have to cross my charges. So for example, if I'm given manganese 3 oxide, I know the charge of manganese is 3 plus, I know the charge of oxygen is 2 minus, so I'm going to cross my charges and that becomes Mn2O3. That should be review. The new concept is if I have 2 nonmetals and have covalent bonding as a result. So to write the formula, I'm going to take the prefixes and simply write the formula using the prefixes. So sulfur dioxide tells me I have 1 sulfur and I have 2 oxygen, so the formula is just going to be SO2, and that's it. Now how do I write the name if I'm given the formula? Well, if I have a metal and a nonmetal and I therefore have ionic bonding, what I'm going to do is I'm going to write the name of the metal. Now after the name of the metal, if I don't know the charge of the metal, meaning it's a transition metal, I'm going to write that as a Roman numeral. Then I'm going to write the anion. Now if the anion is not a polyatomic ion, I have to add IDE to the end. So for example, MnS. Manganese is a transition metal, so I do not know its charge. Sulfur has a 2 minus charge, which means that manganese has a 2 plus charge. So when I write this, I'm going to write manganese, then I'm going to put its charge, 2, and then sulfur becomes sulfide because sulfur is not a polyatomic ion. Now if I have a nonmetal and a nonmetal, so covalent bonding, what I'm going to do is I'm simply going to use the prefixes to write the name. So if, for example, I have CO2, that means I have 1 carbon and 2 oxygens. So the name would be carbon, because I can't start with mono, carbon, and then it would be dioxide, and that's it.